Hi, I'm Simon from Micobo, and I'll try to answer all of your questions regarding Micobo's Ethereum-based security token. Why do we need a special token for securities at all? Can't we just use an ERC20 token? Standard ERC20 tokens can be transferred to any Ethereum address at any time, and that's great. But in a regulated context, we need to put certain constraints on our tokens. This is why our security token has constraint modules. They are separate smart contracts that can enforce special rules before a token transfer can take place. The main token contract will consult every activated constraint module to see if the transfer can be executed. If one of them says no, the transfer is cancelled. Let's have a look at some of the applications of constraint modules. A whitelist is probably the most common constraint module. When people go through our KYC, we put them on an on-chain whitelist so that when they try to make a transfer, the smart contract will know that they are allowed to do so. This way, you can make sure that your token will only be traded or possessed by people who are on this whitelist. Another common application is the use of a locking constraint module. For example, we've used it when we wanted to lock tokens for a period of time to later burn them and issue the real shares that the token represents to the user. For this process, because it takes a little longer, we are able to lock the tokens so that they cannot be transferred, for example, for 1 week. During that time, we can give out the actual shares to the owner, and if the process succeeded, we can then burn the tokens. Our token features a simple but effective role system. Different roles can be assigned by somebody holding the admin role, the first of which is set during token creation. The most important roles are the admin. The admin is the most important, most powerful role. You can assign or remove other roles, meaning you can give people the ability to issue or to burn tokens, for example. The controller. The controller is also a really powerful role. Anybody who has this role can do so-called forced transfers, meaning they can move any tokens from any address anywhere else. This is strictly and only meant for emergencies where people have lost their private keys. And since this role is so powerful, you can deactivate this function altogether later on. The issuer. The issuer or minter has the ability to create new tokens as long as the maximum cap of the token allows it. The redeemer. The redeemer or burner role is also a very important role. By default, burning is not allowed, since users should not usually be allowed to be able to destroy their tokens. Anybody who does have this role, though, can destroy tokens and could even, if they are made the operator by some other user, destroy tokens of somebody else on their behalf. The Modul Editor. The Module Editor can activate or deactivate the constraint modules for the token. That means it is this person that will activate the whitelist or time lock module, for example. The pauser. This role has only one very specific purpose, which is to be able to pause all token transfers completely. This is also something that is made for emergencies, so that in some scenario where all token trading needs to be stopped immediately, you could do that if you had this role on a smart contract level. The constraint modules themselves actually also make use of the role system. For example, the whitelist module needs a whitelist editor role, and this person is able to actually edit the whitelist and add or remove people from it. The cool thing here is that When we create new constraint modules, we're also free to create new roles for them to use. This is because the roles are simply addressed in a mapping using their name. One of the ideas with this very granular role system is that each of these individual roles can be given to, in theory, a different institution or company. That means that the responsibility for different things handling the token can be distributed in any way the client wants it. So let's talk about what happens when a new token is actually created. This works in a very special way. There is an existing contract on the Ethereum blockchain already, which is called a factory. This is a contract that we uploaded some time ago, and it knows the location of the standard logic contract, which is another contract that we've uploaded some time ago. When you want to create a new token now, what happens is you send a normal transaction calling the function to create a new token to this factory. And then this factory will actually create a new contract, a proxy, which is going to point to the other logic contract that we mentioned. So you actually don't upload all the token contract each time you create a new contract, but instead you create this little copy of it, this little shell, which points to the logic contract. Okay, so how can a existing smart contract be updated? I thought these smart contracts are non-changeable. I mean, that's the whole idea, right? So how exactly can we achieve some sort of updatability here? All right, let's look into it. The main thing that happens is the factory contract that I've mentioned that knows where the logic is will receive an updated logic location from us. So what we do is we upload a new standard logic for our token contracts, and we put that on the Ethereum blockchain. We then, secondly, tell the factory contract where this new standard logic contract can be found. And from that moment on, every new token that is created will use that new standard logic instead of the old one. And additionally, all of the old tokens that already exist, which if we remember are also simply proxies pointing to that old logic contract, they can now, if you have this specific role of the admin updater, you can now call your proxy contract and tell it to, from this point on, use the new logic contract that we've updated instead of the old one as well. So this means that as the person who deployed the token contract in the first place, you are also responsible for deciding whether you want to update your smart contract or not. This means you're always in control. Updating a smart contract can have various consequences. We might have changed the way that some of the existing functions work. We cannot delete any functionality. We can only make it void. We can add new functionalities after the fact and add those to the features of the contract. Those will then be included in the new logic contract, etc., and will from that point on be usable in your contract. So that's how we achieve upgradable, updatable smart contracts. One super important and super cool thing to remember when we talk about updatable smart contracts is that our proxy token contracts will actually keep their storage when they are updated. So this means that all the ownership of tokens or anything that was saved and that was changed in the smart contract up until that point will still be saved there. The only thing that would change is the logic of the functions. So that means the way functions are handled when they are called. Nothing will be lost. It'll all still be there. You can set spending limits for specific users. For example, a user could only be allowed to transfer 1,000 tokens every day or 5,000 tokens every month. The amount and time frame here can be freely chosen. Once a limit is set, the module will automatically track the spending of this user and deny any transactions that would exceed the limits. The constraint modules are called modules because we can use them in any configuration we want. We don't have to use any of them, or we can use all of them. We can even come up with new constraint modules, write them, and add them to our security token contracts. For each transaction, the smart contract will look at all the constraint modules that are turned on and configured for this token, and will ask them if the transaction that wants to go through is allowed to. And after all of them have said, yes, the transaction is okay, it will go through. The off-chain module can be used when the required constraints are either too complicated or simply impossible to implement in a smart contract. One whitelist is easy to maintain and only takes about one line of code to check. But what if I need to check multiple whitelists simultaneously, or spending limits based on, for example, users' nationality need to be enforced? Data that is not necessarily on the blockchain, but maybe in a database somewhere. It might become too costly to do these checks directly in a smart contract on the blockchain. So this is where this module comes in, and it will work like this. Only transactions that have a special signature amended to them will go through at all. This signature would come from a third party that controls a specific Ethereum address that the module knows about. This third party would then go and look at every transaction before it is even submitted, and if it approves the transaction, it would put its signature on it, and then the transaction would be able to go through. By using smart contracts as a basis for a security token, features that were previously impossible or prohibitively expensive to implement in traditional financial assets can now be automated. We gathered common regulatory requirements and embedded corporate actions into our security token standard. Thanks to this, they can now be enforced automatically, reducing complexity and increasing contractual certainty.